Let's get started. So, the world has so many problems and only so much money to fix these problems. Should we still fund trips to the moon and space um, exploration in general? So, this unit is all about space. Usually, students really like this unit, very invested in space. However, the TEKs that are assigned for seventh grade for science, space is kind of limiting and does not show up on the uh, eighth grade STAR test. So what I've done, since this is not on any CAs this year, is I've got a jump start into eighth grade space science so that kids have a basic understanding when they start learning about this more in depth in eighth grade. Um, it ends with a project where students get to explore any part of space that they don't know about yet that they're interested in, and there are some questions that kind of align to this main question I have here: is should we still be spending money on this, even if there are so many other problems in the world to fix at this time? So we're going to go over the priorities for CAs, the explanation of the order of objectives that I've chosen, key misconceptions that students have during this unit, the project explanation, experiment setup, shopping list, and then our general end goals. So again, just like I said in Unit 6 on that preview video, there is no content on CAs that have to do with space or Earth systems, so there is not really any alignment between the CAs and what you need to teach for this unit. What I would focus on is making sure that the questions you ask are aligned to the 8th grade STAR if you plan to use the objectives that I've laid out for Unit 7, which are mostly 8th grade TEKs. So looking at the unit plan, you can see that the statement of inquiry is patterns in the universe affect our daily lives on Earth. This statement of inquiry really can apply to every single lesson that we talk about. Everything that we do on a day-to-day basis is really influenced by how long the day is, what the weather is like, etc. It impacts so many different occupations throughout the world, so many different how our clothing is made and whether we choose to go outside. It affects sales, if it affects world hunger, etc. Going back, it should be about 9 lessons. It is the last official unit of the 7th grade curriculum, other than scientific investigations, MYP investigations at the very end of the year. But this is the last unit preview that I'll be making for 7th grade science. For the Unit 7 project, there is, of course, an MYP assessment that you can look on and copy from online. However, there's also a project which is a pretty open-ended project for students. It's just an opportunity for them to research whatever topic about space that they're interested in and provide a presentation to the class explaining what they learned. So they are acting as a researcher. They get to choose their own topic, and then they can present that information in a variety of ways. They can have a PowerPoint, a poster, a skit, a newscast. Really, it's open-ended. It's the end of the year, and I'm hoping to get kids in their creative frame of mind. So the order of objectives, this starts right after the writing star. The writing star kind of is in the middle of this. So we start with just a basic introduction into space, all the different celestial bodies. Some students learned this in 6th grade, some of them didn't. It's a quick overview of space and what they should know so far. Lesson 2 is all about our solar system, our 8 planets, where they are, what is the difference between them, basic information. And then lesson 3 is where we start talking about 8th grade TEKs, starting with the seasons. And then I move into a quiz at that point where I give students another opportunity to make a seasons model, and then we start the moon phases, which is very important to do before you start talking about tides, because tides are very closely related to where the moon position is in relation to the sun and the earth. And then the end of the unit, of course, is the project and the assessment. Common misconceptions for this unit: students have a really difficult time remembering the difference between a meteoroid and an asteroid. They usually get them mixed up, or they can't remember that a meteoroid has kind of 3 different classifications, either a meteoroid, meteor, or meteorite, depending on its location in relation to the Earth's surface. Students have a very difficult time remembering which is a terrestrial planet and which is a gas giant. Lots of models are super helpful with this. Students have a really do pretty well understanding how the seasons operate. However, if there's a multi-step question where they have to determine which hemisphere is the question talking about, and then figure out which hemisphere is pointing towards the sun, they have a really hard time understanding when fall and spring is as well. They're really good at summer and winter, fall and spring not so much. Students have a difficult time past the memorization point for moon phases, so they usually can figure out what all of them are, but they frequently flip the sides that the white part is on. So for instance, they'll get waxing crescent mixed up with waning crescent just because they put the white part of the moon on the wrong side. And then students really have a hard time understanding what is the difference between a high and low versus a neap and spring tide. They think that spring tides are high tides and neap tides are low tides, but that's really not the case. So being super clear, giving them lots of opportunity to practice is really important in this unit. So let's talk about the project. Students will create a short presentation explaining the phenomena in the universe of their choosing. As a group, and you can do this individually or as a group, students can decide on a topic that interests them and then complete a research page together and then present that to the class. So some things that they could research is how to become an astronaut, what is the Big Bang, what about other galaxies, constellations, dwarf planets, aliens. Really anything that they want to research is fair game, as long as there's some actual research to back up what they learn. If they're just Googling weird alien problems, then that might not be a great project, but figuring out different phenomena could be really interesting. So half of their points comes from the research that they do, their behavior, their sources, their participation, and then the other half of the points comes from how they choose to present the information. So it says presentation poster, but it doesn't necessarily have to be a poster. It could be a PowerPoint or a handout or anything like that. So this is separated into 2 days, the research day and then the presentation day. As far as experiments go, this is the very last unit. There's not many true experiments. There is some materials required for a seasons model. You might need a paper plate, colors like crayons or markers or colored pencils, glue, scissors, etc. And in the moon phases, you will need 8 Oreo cookies for every student, or you could do it in groups if you want, and then you need 8 Oreo cookies for each pair of students. If you choose to do the moon phase Oreo cookie lab. Lastly, really what students should be able to do at the end of this unit is to create models, whether that be of the Earth seasons, moon phases, and tides, be able to answer questions based on a model, be able to create their own model, and be able to explain how the model is related to and different from real life. If you have any questions about Unit 7, please feel free to contact me at alawrence@uplifteducation.org. Thank you very much.